Welcome to Joey's Tech. You are going to learn all about Python generators in this video of Joey's Tech, which is one of the favorite topics of the interviewers. Plus, it is that one feature of Python which helps you as a programmer to make efficient memory use just by writing a function and putting a line of code with yield keyword in it. Well, let me tell you what you will learn in this video. You are going to learn how a generator function is formed, how you can convert a normal function into a generator function, how the generator implements an iterator, and a little bit about what iterators are in general. When we talk about generators, then we should also know that what generator objects are, so that you are going to learn in this video as well. The next method, which is used to access the values returned by generator functions. And then finally you are going to learn how to use for loop, yes, the classic for loop, to access values returned by generator functions. All these topics you will learn in this video, so I repeat, do not skip any part of this video, because the way I'm going to tell you these topics is through hands-on and not theory. So if you skip any part, you are going to miss the link. Also, if you want to grow in Python exponentially with a strong foundation, then you should subscribe to my channel Joey's Tech if you haven't already done it yet, and hit the notification bell so that you get notified the moment I release videos like such. Alright, this is the PyCharm IDE in which I am going to write the program. If you don't have it installed on your machine, then you can download it easily by watching this video in the I button. To begin with, we are going to write a simple function. We will call it simple underscore generator, within which we are going to simply write a line of code, yield 45. This 45 is some random number that I just thought of, so don't think about it having any meaning related to this program. So let's write it down. I'll write def simple underscore generator. Within its body, I'm going to write yield 45. Alright, so this is our generator function created. Do remember, if you add a line of code with yield keyword in a function, it becomes a generator. And that's how you turn a normal function into a generator. In other words, a generator function must have a line of code with yield keyword. I've made a complete video on yield keyword in Python, which sets the foundation stone for understanding generators. You can watch it by clicking on the I button. In the main function, let's call this function and print its content. So it will be main, within which I'm going to simply print simple generator. Let's run this program quickly. You see that the program prints a generator object. This generator object is an iterator. We can access the generator object that is an iterator using either the next method or using the for loop. You know, it takes some effort in Python to create an iterator. You need to create a class that must have methods iter and next. But when you create a generator function, iterator automatically gets created for you. That's its biggest use. Now we'll create a more sophisticated generator function to see the use of the next method to get the value of the iterator, which is the generator object. So it will be def, and we'll call this generator as infinite generator, within which we are going to declare and initialize a variable to 0, and then we'll write a for loop which will have the condition as num greater than equals to 0 colon. Inside this, num is going to progress. It will be incremented by 1. And as the last line of this generator, I'm going to simply yield num. You can see that we have written a while loop that is going to run for infinity. This is seriously not recommended, but for understanding generators, this program is important. We go to the main function now and receive the generator object. And we receive it in a variable. So it will be x followed by an equals to sign, infinite generator. And now we write 2 to 3 lines of code in which we use next method to print the values returned by the infinite generator on the console. So it will be simply print next, and within its brackets we'll have to pass the generator object, which is x. I'm going to copy and paste it 2 more times. That's cool. Let's run this program. But before that, I'm going to comment this line out because it may confuse us a bit. See the magic. First infinite loop in C many years ago, I had to shut down the window to kill it, but over here, nothing of that sort is happening. This is possible using generator functions. The entire sequence of infinite values is not getting stuffed into memory, and you're not seeing any kind of abrupt running of program over here. Generally, if we write an infinite loop, then it starts producing values and it doesn't stop. But anything like that is not happening over there. But anything like such is not happening over here. So the entire sequence of infinite values is not getting stuffed into memory. Rather, only when you call the next method on the generator object, the value gets printed. The next interesting thing to note is how the value of variable num from our generator is remembered between each successive function calls. When we are calling the next method the second time on the generator object, 2 gets printed, which is the next value of num after 1. This implies that the generators maintain the state of the local variables when it yields for a particular generator object. This also means that if a new generator object is created, then the loop starts all over for the new generator object. Let's test that out. So I'm going to simply write y, which will be my new generator object. I'm going to simply copy this infinite generator over here, and then I'm going to copy and paste these 3 print statements, and I'll replace x with y. Okay, let's run this. It should print 1, 2, 3 again. There you go. This proves that when we want our generator function to start all over, we need to create a new reference to the generator object. So this y is our new reference to the generator object. This x is our reference to the generator object, or a holder of the generator object returned by this generator function. Now you see that the value is getting printed only when we are calling the generator object using the next method. So generator function is only giving us the values when we are asking for them. This proves that Python gives you the facility of lazy evaluation through generator functions. My friend, I'm doing my best to explain to you generators in Python using various scenarios. I say if you're liking my explanation, then do hit the like button to show me your encouragement. Now let's create one final generator function. We won't go on an adventure this time like we went on with the infinite for loop. So it will be def even underscore generator. That's what we are going to call this particular generator function, and we are going to declare and initialize a variable n to 1. Then we are going to start a for loop. The condition will be n will be less than 10, and within which there will be an if statement which will say if n %do comparison operator 0 colon, if the execution goes inside this particular if statement, if the execution goes inside this if condition, then it yields n, and outside we will increment the value of variable n after each iteration. So the logic is pretty simple. This particular generator is generating even numbers between 1 and 10. Now let's print these even numbers returned by this generator function even generator in the main function. First of all, I'm going to comment this out. So first I'll create a generator object. I'll call it eg, followed by an equals to sign. I'm going to simply write even generator, and then I'm going to make use of the next method within which I'm going to pass eg. I'm going to copy and paste this line of code 4 times because there are 4 even numbers between 1 and 10. Let's run this program and check what output it gives. You can see that our generator function, which is even underscore generator, is returning 2, 4, 6 and 8 as expected, because there are 4 next method calls on this generator object. Now what happens when I call the next method on this generator object again? Let's check that out as well. I'm going to run this program. All right, you can see that a runtime exception stop iteration exception has been raised. Because in the fifth generator function call using the next method, it has no value to return. It is done, terminated. So this is the disadvantage when we are trying to access values returned by a generator function using the next method. When the function stops, when it has no more values to yield or return, then stop iteration exception will be raised and you are going to get a runtime error like this. So what can handle this stop iteration exception? The answer is for loop. The for loop has the inbuilt capability to iterate over an iterator using the next method and gracefully stop when the stop iteration exception is raised. So let's make the change. What I'm going to do, I'm going to comment these lines out and then I'm going to simply write for I in EG. That is my generator object, colon, and I'll simply print I. Let me run this program. There you go. You can see that the output is the same and no runtime exception was raised this time because it was handled by the for loop. This is the advantage of using for loop over the next method call. Plus, we didn't have to write 5 statements this time to access all the values. Hence, in this video, we have covered how a generator function is formed, that is using a yield keyword, what are the necessary methods of an iterator and how generator function sends back an iterator. Yes, you learned that. What generator objects are, true, e.g. in this case is our generator object, how to use the next method to access values returned by generator functions, and how to use the for loop to access values returned by generator functions, which is also a way to gracefully handle the stop iteration exception. With this, we have come to the end of this video. Do let me know if you have any doubts related to Python generators in the comment section. I look forward to helping you with Python programming, and only for this video, goodbye and take very good care of yourself.